Hello and welcome to one more session with Professor Sukumar. Professor Sukumar was an accomplished chemist, quantum chemist, before he decided to move to the dark side of life sciences. He is a computational chemist who works extensively in medicinal chemistry and has worked in and studied in US, Germany, and India. His work is of stellar importance. He was one of the first people in India to use AI for drug discovery. So he was a pioneer at that. And we have had the privilege of publishing a very thought provoking book, which I think will have a huge mark in the field. The reason is that artificial intelligence, computational chemistry, computational biology are having a watershed moment. It's a watershed moment in how pharma operates. It's changing, and what he's been able to do in just slightly over 100 pages is taken us from uh, antiquity to the conventional drug discovery and through all the major streams of how computation is changing drug discovery. It's not an easy feat. It's a sort of a second book from our company on the topic of drug discovery. First was written with Ramesh and all. I made minor contribution, and some other scientists in my company made minor contribution, but it was mostly written by Ramesh. And we didn't expect that within 6 to 8 months we'll have another one, and this one leaves everything that we published far behind. So very happy. It's an honor to be with Professor Sukumar.
Thank you.
So this will be sort of our last session. I would like to ask Professor Sukumar, where does he see the future of drug discovery, especially computational drug discovery?
Okay. So, before I get to the computational part, we do have now a far deeper understanding of biology, and I think that has contributed a great deal uh, to you know to reviving the drug discovery process, which at some point had become kind of reached a plateau. Right?
Yeah, absolutely. Very few new antibiotics. We kept hearing
Exactly.
the last 20 years we were hearing no new antibiotics.
Exactly. And a lot of that was because we really didn't understand the biology,
Yeah,
whereby we do now.
yeah.
Coming to the future, I think I do see a much bigger role for computation and for AI in the drug discovery process. Uh, like like we said, just to recap something which we already talked about in an earlier episode, what we want to do is to be able to develop reliable, robust drugs for life-saving drugs faster and cheaper. In the last 30, 40 years, it's been something like $1 billion and 10 to 15 years to develop a single drug. We want to use AI to be able to hasten the process.
Yeah.
And to screen a large number of molecules, we want to be able to fail faster, fail cheaper, so that we fail in the molecules that fail in the earlier stages of the drug discovery rather than later stages when a lot of money has been invested already. Now, the thing with AI and with deep learning, which is going to take a much bigger role in the form of generative models. That is, that the algorithms will generate new molecules which don't exist yet, which haven't been synthesized by the chemists yet, haven't been tested in the lab yet, and they will generate them based on the properties of known molecules. So they will, the models kind of learn the relationships between existing drug molecules and generate new molecules which look like them. Now, what the pitfall here is that uh, whenever you do statistical learning, you can interpolate safely. Extrapolating outside the the domain of validity of the model is always dangerous. So, like you can that if, if you have a set of points in here, then and if you know these points, then you can say, okay, what is in between, you can probably predict. But what is way out there, you don't know, because you don't know whether the line is going to go linear or whether it's going to go like this or whether it's going to go like that. So if we have a set of similar um, molecules, let's say aromatic molecules, with a certain type of ring, and we can safely predict what another molecule which has the same kind of aromatic rings and has the same kind of shape and structure, what activity, what properties it will have. But uh, using data on these to predict some completely different molecule, let's say an inorganic molecule, which has completely new elements. It's like using the behavior of humans to predict what, say, Martians might do, right? So, and but this is what the generative models actually are doing. They are generating models outside the domain of applicability. So, what is going to be essential here is a validation. And without validation, I don't want to take a drug that's just been developed on the computer without any testing and swallow it. Right? I don't want to do that. I don't think you want to do it either.
So, but the validation also is having a lot of role of computation now. So, how you can make validation cheaper and faster? Let me teach you. So, I'll not name companies because I don't want to advertise my competitors. I might just run so much upkeep and I'm hoping to become big. So, but there are people who are going through videos more than the whole Hollywood has produced in just few months of cell cultures. And just based on image, you can predict whether this is going to be useful for X or Y, or this is having a particular impact in cellular transportation. So instead of screening just, let's say, what we are conventionally used to doing, I'm not saying this is the only way. I'm just giving you one example. That just looking at how the cellular structure, anatomy, and morphology of a single cell within that whole cell culture is changing is being used to actually validate a lot of things at the first level itself, whether it's going to be bad or not. Uh, you basically, computers are processing through terabytes of data every second, and it's insanity in terms of how validation, even the validation, other aspect of validation is to have robots. Where when I was a student, we used to complain about pipetting. I mean, still, yes, a lot of biologists unfortunately are being used as cheap labor, but the value of pipetting is going down every day because robotic stations can do most of the job. So most of them, not just the creative jobs, even non-creative jobs, AI is coming for you from the job angle. But from the angle of validation, computation, AI, robotics, they're playing a huge role in validation also in making that process faster, not just the prediction part faster.
Right. And even the generating the data. So the thing is that the, the traditional statistical models have used small data sets. And to use the techniques like partial least squares, support vector machines, random forests, and make models on a few hundreds to a few thousands of molecules. Deep learning requires huge amounts of data. That's because it has a huge amount of free parameters, like GPT-4 has something like 100 billion parameters.
I think slightly more, but
Yeah,
it's at least 100 billion, if not more.
Yeah,
I think.
hundreds of billions of parameters.
Yeah.
So it requires a huge amount of data to train. Now, how do you generate that much of training data? Training data means you need to have a molecule and you need to have the drug activity. So are you going to feed? Are you going to have so many patients? That's not possible. Even so many rats, experiments in a billion rats is not possible. But what is happening is that fake data are being generated, and also data are being trained, and molecules which look like the existing known molecules would be trained. So, there are various techniques which are used, uh, which include transfer learning, reinforcement learning, whereby and one-shot learning, whereby even though you might not have a lot of data for this particular disease, you have a lot of data for other diseases. So you can learn some general properties from all this other data.
Yeah.
And then when it comes to this particular disease, you can use the few data that you have, but leverage all the information that you have learned in order to make a model for this.
Yeah, that's absolutely fantastic. I've not heard anyone in a podcast discuss the value of transfer learning, which is huge for drug discovery. So, this has been transfer learning has been hugely used in self-driving cars. It has been used hugely by companies like Boston Dynamics and all for their robots. Transfer learning is just beginning to be, we're just starting to scratch the surface of it for drug discovery, but that's going to be hugely transformative in future. So it was an absolutely stellar session. Thank you, Professor Sukumar.
Thank you, and it was a pleasure to meet you and to do this interview. And thank you for coming.
Thank you.